Greetings, everybody. If you've clicked on this link, you are now listening to and watching Tableau Tuesday's presentation of Tableau relationships. Thank you for attending. For those of you who previewed pre-releases of Tableau, you might also know Tableau relationships as the object model. And if one were to make a bet on what t-shirts will have on them, there's a good chance that you will also see the noodle. So if you think about all of these names, they're nouns except possibly the noodle, because you can also think of this as a verb. For instance, have you noodled your data yet today? Or go noodle that in Tableau. And my favorite, let me noodle on that, which would imply that to noodle is to think. And so, given that Tableau has the noodle in it, would that imply that Tableau thinks for you? I would say you can make that decision at the end of this presentation. But in the context of Tableau's new relationships, the answer is a resounding yes. So, in this presentation, we're going to cover what relationships are, why we did it. We're going to take a closer look, and there will be a couple of demos intermingled within, and we'll do a little bit of wrap up and even share some nuances and observations that you yourself might discover as you're learning this new capability. Before I dive in, just a little bit about myself. My name is Scott DeVillers. I'm a principal solutions engineer with Tableau, and I have been at the company since 2012. So one could say I've seen quite a few fundamental changes in the product. We were in version 7, in fact, when I first joined. Tableau level of detail calculations came into the product in version 9. And you could say there have been several other groundbreaking or quantum leap forward innovations built into Tableau as well. We'll see a timeline in just a sec, just to see what some of those are. A little bit more about myself. When I'm not helping customers see and understand their data, I'm out there generating it, then of course, seeing and understanding it later myself. And I'll drag in as many other like-minded individuals as I can to go with me. And so that's what I like to do for fun, among many other things. Here is that timeline I just mentioned. So Tableau got started actually in the year 2003, and there just isn't enough room on a slide anymore to really cover all of the innovations. And of course, we're only really showing some of the highlights. So prior to 2009 and really up until about 2013, the pace of innovation has been relatively flat. We were doing general releases on an annual basis and then patch releases quarterly, but we have since started doing much more frequent major releases on a quarterly basis with patches in between those. And you can begin to see that the frequency as well as the volume of innovations increase as well. So in version 9, which is right around the 2015 timeframe, is when we introduced level of detail calcs. There's a reason why I've mentioned that twice already. And what you can also see quite a few other, some of them groundbreaking, some of them maybe not so much so, and then of course the version numbers at the bottom. In fact, this innovation slide isn't even the most current for the way forward as far as figuring out what new innovations came in what releases. There will be a link in a slide deck made available that you can use to follow and see what you might have missed if you're jumping from 2019 to 2020.2, for instance. And you can look at all of the different high level as well as lower level innovations added to each of the versions as we've released them, and go as far back as you need to. So why did we do this? Imagine not having to know what a join is, what a relationship between a table on a certain field needs to be like, whether it be left, inner, right, or outer, for instance, or having to be a DBA and know advanced concepts as far as modeling data, and yet to be able to pick up Tableau connect a couple of tables and start making really good decisions based on the correct answers every time? Well, you can do that with logical relationships in Tableau, because Tableau will automatically form the correct joins and the join types for you. Instead of you having to anticipate it in advance, it will actually defer and happen as you analyze the data. So you may be using any combination of those join types as you're aggregating and asking questions of your data, and Tableau will figure out the right relationship and join type for you as you go. Imagine the usefulness and the power that this will bring to a much broader audience of analysts. So let's take a quick peek at that, shall we? So imagine the veterinarian who sees patients on a regular basis. Imagine what the data might look like for a day-to-day type of business like this. You have essentially what we have here are 4 tables laid out in a relatively simple relationship. They're oversimplified to make it easier to understand Tableau versus being challenged by data that's a little maybe too complex, at least when you're first learning relationships with Tableau. So the customer table, for instance, has a customer uniquely identified by customer ID, and you can think of it as an aggregate table maybe, or a summary table at the customer level. For the purposes of this demo, in any case, the customer table is related to the animal table by the customer ID. So a customer may have 1 or more animals. We would see that customer ID more than once, for instance, in the animal table, if that were the case. And similarly, an animal can have 1 or more appointments, and we're seeing the relationship between animal and appointment. And as we go further to the right, we can see something similar going on at the prescription level, where a given prescription has a certain appointment and ID, and of course, more than one prescription can be prescribed per appointment or on multiple appointments. Taking a closer look at the actual data of the same 4 tables, again, very simplified. This is all the data that there is in this particular data set. We have 1 customer, customer ID of 1 named Ginger. And again, think of this as an aggregate or a summary level table, not necessarily the actual dimension table containing all customers. The real reason for this is so that we can make it easy to see the total spend, which is really no more than an aggregate of the billed amount for every appointment for that customer, as well as the price for any prescription to that customer's animal, added together to get this number of $1,350. So the appointments adds up to $700 and the prescriptions adds up to $650 here for your convenience, and you'll see later in the demo where we use it as well. So Ginger has 1 animal named Spot, animal ID of 1, belonging to customer ID of 1. And here's where we would see customer ID of 1 for any additional animals Ginger might own, or additional customers if we had more than 1 customer. Spot weighs 35 pounds. And then at the appointment level, we can see, well, quite frankly, Spot is having a rough April. In the beginning of the month, on successive days, Spot came in for an 8 and an 8:30 appointment. You can see the billed amounts. And if we follow those appointment IDs down to the prescription table, we can see that on those first 2 appointments, heartworm medication, skin cream, and flea and tick medications were prescribed. Not so bad, but by the middle of the month, we can see things may have taken a turn for the worse for poor Spot, and we've got painkiller and antibiotics being prescribed as well. So that is essentially the data that we're going to take a look at. But in order to understand what's new in Tableau, it is easier to understand that by contrasting it with what is old. So we're first going to take a look at this data set in 2020.1, and then we're going to take a closer look at it and see the differences in how it works in 2020.2. So we are in 2020.1 right now, and we'll start by taking a look at what the data set looks like first before we start looking at any of the data. So in order to bring together all the data that we just previewed, and there's an extra table over here on the right, which we may or may not use. for the sake of argument, let's just remove it for now, and we won't even worry about that one. So those 4 tables we just previewed are joined, and we have predetermined the join type, right? So we have an inner join on customer ID between the customer and the animal table, and between animal and appointment, it will be on the animal ID, same relationship, inner join, and so forth. Not necessarily knowing every question I'm going to want to ask of this data, I am deciding in advance on an inner join. And by bringing these 4 tables together as they are, with those join types, we have predetermined the actual merged table that those joins in those tables represent. So this is essentially what I am going to start with, this result set, if you will. If you think about a select all from, you know, everything, all tables, all relationships, this is what it would look like. So let's go ahead and start analyzing. First off, let's go ahead and remove that from the table I removed. It's used somewhere else, so it doesn't matter. Actually, let's go back and add that table back in because I'm going to need it. So this is the experience, of course, when you create these joins, you're picking whatever the related column is to the related column of the other table. So there we go. That should fix that broken calculation. There we go. You'll see why I needed that. So that was my bad, actually, for taking that out. All right, so if the first question is, what is the total spend of either all customers or in this case, just one customer, because that's all we have, one could simply drag total spend out from customer, right? So keep in mind that when we create a data source, however many tables we might bring in, one or many, we will see all of the dimensions that Tableau has helped determine for me, and I can override that. And we will see all the measures down below. We'll have a single pane for measures, and we'll have a single pane for all of our dimensions. Okay, so I have gone ahead and made it easier to select my measures. So total spend, I can simply turn on, and you may have noticed when we preview the data, and remember that number of 1,350 total spend, but when we bring it in here, we see a much larger number. And that would be true if we were to do the same thing with the weight of Spot, for instance. It would get added up to some larger number, and we know Spot weighs only 35 pounds. We also know Ginger has only spent $1,350. So why is that? Well, it's a level of detail issue. We are analyzing data across tables of different levels of detail. And so for those who have been using Tableau for a while and know what's going to happen and know how to get around this, they may have started writing, taken advantage of those level of detail calculations that I mentioned earlier. So we've gone ahead and pre-written one that takes advantage of that customer table that has that total spend in, right? It's a fairly simple one. We have the advantage of having that one table and the right level of detail in that table for this calc. So fixing it on the name of the customer, we can simply grab min or max of spend, and we end up with essentially that customer spend being what we want, right? So that table calculation fixes that problem for us. And if we didn't happen to have the luxury of a table that has everything at the level of detail that we want, or at least at this level, then we might have to write another calculation, a different calculation that looks more like this, where in this case, the price of prescriptions is at the prescription level. That's a different level of detail than the actual appointment. We've had 3 appointments, right? But we've had 5 different prescriptions. So we need to actually specify the right level of detail for each component of this calculation, which when added up will and should give us the same number. But what if we didn't have to do this, right? Well, first of all, why is this happening? Might be a better question to answer, and then we'll move on to that second question. So as you can see, by bringing out the different levels of detail, remember for date, we only had 3 different dates, but we had 5 different prescriptions, and we're repeating the spend for every row that we bring back. When we add totals to this, we'll see it added up to $67.50, which is not the right answer, of course. Now, Tableau has made totals a lot more flexible as one way to deal with this. So in this case, we can actually set it to something like an average and get the right number. We would have had to know to do that, of course. So that's one thing we could do. But it does require somebody needing to know that they needed to do that. So let's take a look at the other solution, which of course is using relationships. We certainly don't want to see this happening, right? Join explosion, which is another term for what you just saw. Certainly funny for those watching, maybe not so much for this guy, and certainly not funny in the real world when you might be making decisions based on numbers that are incorrect. So again, Tableau 2020.2 is what we should be looking at right now. And let's first start by looking at the data set. So here's where we left off. We are using a joins data source, not one that uses the relationships, by the way, first off. The reason for this is I wanted to show you, for anybody who is wondering what's going to happen with any data source I create with any other version of Tableau earlier than 2020.2 when I open or bring it in to 2020.2. And the answer is this. What you get essentially is a single, we'll call this a logical level, named merged data, which indicates that that's where all of your tables are, your physical tables. So the result set is the same as what we saw in 2020.1. And if we double click here, we can come down to the actual physical layer, seeing all of those joins the way they were. So to answer anyone's question on, gee, now that I've got relationships in Tableau 2020.2, and I'm panicked now about what's going to happen to my data sources when I start migrating them in, the answer is absolutely nothing. They will continue to operate and work identically as they were before. So you will not have to update them to the new relationships. You can continue using them as they are, and you are not required necessarily to make changes. Hopefully you will understand why you might want to, but the answer is you will not need to. So this is the physical level of essentially what we have as a logical way of bringing tables together. So that is how things look in the old way. And if you want to look at the way we might put this data source together the new way, we'll switch to that other data source using relationships. Kind of looks the same at first, right? All the tables are in the same order. They're connected, but they don't have join types, right? We are simply saying these tables are related by these fields, and so on as we move across. And what's more is we are only seeing each and every table at its original structure and level of detail. It's because we are not actually creating a merged result set out of all 5 tables. We are leaving each table at its own level of detail and granularity. So there's the animal table, here's the appointment table where we have 3, and here's the prescription table, and of course the details about the prescription table to the right of that. Right, so that's the first difference you're going to notice when you start building new data sources in Tableau 2020.2. So let's go to the scenario A and see, again, we're still using the old way, but we'll just switch. And what you're going to see, of course, is we don't really need either of these 2 level of detail calculations. This number will end up being the same as that one for this relatively simple level visualization. So let's go ahead and replace with the newer one. And there we go, right? Don't need these 2 LOD calcs. So will I say that you'll never need a level of detail calc again? Nah, that's not necessarily true, but you probably won't have to write nearly as many of them. Now, if we were to build it out to the same level of detail like we did before, and we see that row replication or repeating numbers, Tableau is still smart enough to give you the right answer, even if you were to ask for a total. All right, so since relationships are new to you, one of the first questions might be, how do I learn more about them, right? And so what you're seeing here is a snippet from Tableau's e-learning, which of course is your way of doing your own self-paced journey through all the different courses Tableau offers, good for an entire year, and you can go at your own pace. You can repeat sections that you want to see again. And so what we're looking at here is really a table that helps you distinguish the difference between joins, relationships, and for those of you who've been using Tableau long enough and who need to bring data from many different sources together that may not all be in the same place, you may have also used blends. So what is the difference between the three? If we start at the top, of course, as just explained, a relationship keeps all tables in their original table definition, if you will, or granularity and structure. Whereas a join creates a merged single table out of however many tables are joined. And of course, blends are essentially creating result sets as you use them in your worksheet. When to use a relationship is when you have differing levels of detail across tables that you need to actually analyze, whereas a join you can count on when you know that the row structure across the two tables is the same. And of course, a blend is when you need to combine data from different levels of detail. However, I would say blends might start to go the way of the dinosaur here. They may become more and more rare because relationships should be able to do anything a join or a blend can do for you. Fear not, though, if you have workbooks that use blends or you still want to use blends for whatever reason, you still can. They are not going away. Relationships have context based on how you use them, the actual fields in each table across the relationships. Joins have no context. You are setting that in advance. Blends always do. Relationships are logical. Blends and joins physical. And of course, in the 2020.2 and beyond, it is the default, whereas joins can still be used as well, but it's not the default anymore. And of course, blends still available as well, but also not necessarily the default. So if we take a closer look at what's really happening, and you got a preview when I showed you the veterinarian demo in 2020.2, we came in at the logical level when we went to edit our data source, right? The merged or the migrated data you can think of as logical table A. And when we double clicked it, we saw all the physical tables underneath. And that single merged or migrated data created that merged result set. So if I have one or many tables underneath my logical table, whatever result set these physical tables create is what is going to come out of logical table A. Similarly, if I had another one where I did the same thing out of a different set of tables for my other logical table, that result set would come out at whatever level of granularity those tables dictate. But then I can still relate them logically using a relationship. So when you first start out, you will probably have just one physical table per logical table, but keep in mind that relationships are really powerful and you can actually do stuff like this with them as you get more and more confident. So let's take a closer look and see what more relationships can do for us. Again, starting with 2020.1, and then we'll move to 2020.2 to see the differences. So Minnesota counties. I have two data sets here. Make sure I am in 2020.1. I am. I have two different data sets, one that is all Minnesota counties, and the other, is kind of in the news these days and we're all paying attention to. We have basically counties and the count of COVID cases for Minnesota that I'm getting off the Minnesota Department of Health. So I was interested in pulling these two together just to see how they behave the same and or differently between versions of Tableau. So what I'm looking at right here is simply what came in the all counties data set, which is county, and then we also have a population. And actually, I started with cases. So let's start, first of all, by looking at just county. And you can see, for instance, that by looking at the bottom left corner, Tableau keeps track of how many rows, right? So by just bringing out county, we can see how many counties we have in our data, and it looks like there are 84. And of course, it wouldn't matter if we brought this one in first, because remember, I created, or if you didn't remember, I'll just show you, I created a inner join between the two, right? And so I could start with either one. Here's the counties from the COVID cases data set and have 84. And as far as I'm concerned, being someone who is not necessarily a geography student of Minnesota, that's probably all the counties. I wouldn't necessarily know if maybe that isn't all the counties. Unless, of course, I put it on a map, right? And now I can see that the map is not full and there are 3 missing counties. So that's not a great experience. How can I get all my counties with this data set? Well, okay, if I knew what I was doing and having to go into a data source and change the join type, every time I wanted to ask a different question to get the answer, well, now I've got 87, right? And I look at my map and I see that it's filled in, right? So great, I knew what I needed to do and I went ahead and did it, but should you really have to do that for asking and getting answers to new questions or different questions as you go? And of course, the answer is no. It's not a great experience, and you certainly don't want your end users who are maybe using web edit to try to get answers to questions, or who just don't have access to modifying data sources to have to do this. They can't, right? And they shouldn't have to even if they could. So how would that look in 2020.2? Same data set, right? So let's go ahead and take a look. First off, I want to point out another new thing that is really important. I'm going to use quite a bit here. There are quite a few tables in the veterinarian's data source, so I'll explain it by using one that's a little simpler. The first thing you might have noticed when you look over here at our data window, if you will, is that we no longer have an upper area for dimensions and a lower area for your measures. Rather, we have dimensions and measures for each and every table. Why is this? There it is for counties and the population. The reason is we are not creating a merged data set with only one number of records count that would be accurate for every table. So rather than having that, we have measures and dimensions for each and every table. And instead of the number of records, we now have a count of rows that's given a name of the table itself so that you can see each one distinctly. So here is essentially your measure or your number of records for your COVID cases data set, and here's your number of records for your all counties data set, all right? So first things first, if I start the way I started in the other data set and just brought county out, how many counties has Minnesota? The answer is 87, right? And because I didn't necessarily know all my counties, I wasn't able to tell A, that I actually had fewer, or actually had more than I was looking at. There's actually 87, not 84, and let alone which ones they are, right? Now, if I bring the other county field out from the COVID county data, the cases, counties with COVID cases data set, suddenly it goes back down to 84 again. Why is that? The answer is for performance reasons, Tableau has decided to use an inner join when you're only working with dimensions and you have yet to bring out any measures, okay? So at this level now, I can go ahead and bring out cases, for instance, or I could go ahead and bring out population, right? Either one. If my next question is, of all the counties with COVID cases, you know, how many are there? So I can bring cases out in each county. And we can see all of a sudden, now we have 85, right? We had 84 when we were looking at just county to county, but remember, bringing in a measure forces Tableau to use the proper join so that you're not missing any data, really. For instance, if you didn't know that in the counties with COVID cases, there was a record that actually didn't have a county name in it. Rather, it had this value called unknown missing. You might have missed 20 cases of COVID, right? And of course, it's null in the county list because there is no county named unknown or missing. But in the counties with COVID cases, there is one. And what it means essentially, after having done a bit of research on our Department of Health website, is simply that new cases that are being essentially evaluated, folks are being interviewed, they're figuring out where people are from, where they live, where they were when they got the case. Some of them could be from out of state for all we know. This number essentially is sort of in limbo until they decide what county to put them in. So this number you'll see on almost a daily basis as new cases come in, and eventually they will get put in their proper location. So there's a missing row of data I would not have seen unless I knew that I had to go in and change my relationship, my join type in the old way so that I caught this, right? But an end user, an analyst who doesn't understand how to create joins or what they mean when they change the join types should not have to know how to do that just to be able to capture data like this. So that's a plus, right? Now, what if I bring in population? Now all of a sudden I've got 88. So we've seen 84, we've seen 85, we've seen 87, and we've seen 88. Which one is correct? Well, the answer is it really depends on the question. And that's the point I'm trying to make here. So what I just did here is by bringing in a measure from both tables, I have essentially involved both levels of detail in my data set. So to the question of how many counties are in Minnesota, I got that by simply starting off with my counties. And the number was 87. No join was needed for that because I was only using a single table. If my next question is, of all the counties that Minnesota has, which one have COVID cases, the answer was 84 plus that unknown missing, so it was really 85, right? And to get that answer, I would have had to use a right join. Which counties have no COVID cases? If I didn't actually involve the county from the data set with COVID cases, I might have used a left join. And of course, why do I have 88 counties? It's the 87 that I have in the state of Minnesota plus this unknown missing value. That's your full outer join, right? All of those join types happened for me by default. I didn't have to define them. They just happened because of the way I used the data. And in case I didn't demo how I got to counties without cases, let's do it this way. Because it's worth seeing again, especially because these number of record fields are really useful. For instance, if I start with county, and then I bring the other county out, and then I bring in the count from the table with more records, right? There are 3 more counties than there are in the counties with COVID cases data set. I go from 84 to 87, right? Sorry, I got my little buttons in the way, there we go. And if we simply reorder these two, we can actually see, so column furthest to the left is your default sort, and nulls always sort to the top. So this is a good habit to get into. The other one that you may not have noticed is whenever I'm validating data I'm not used to, if I have related 2 tables on a field such as county, it's often useful to bring them both out side by side, especially with the new relationships, because now you can actually start to learn stuff that you might not have seen. For instance, here are my 3 missing counties, and there are the cases right there for the ones that have them, and these are the ones that don't. So that was my left join right there. So why is that handy? Well, now that we know that we've got the ability to relate data safely across tables and have the levels of detail maintained as we use them, we can create maybe more powerful calculations. So here is simply county and population, and I can now build this map a little smarter, right? So let's come back here and build the calcs first. If, for instance, because this is COVID data, I want to understand, on a case per capita basis, what my number of cases are per, say, 1,000 people, well, first off, I may also want to see, instead of zeros in the cases without or nulls, I may want to see the actual zero, right? So a calc, and that way it would show something on the map, and it might also become useful in other calculations as well. So rather than to make you watch me type and make mistakes and back up and fix them, in the style of a good cooking show, I'm going to go ahead and just do that in advance. And let's see, let's name this Cases All Counties. And to the question of, well, do I need to use level of detail calcs anymore? The answer being, they're probably going to be far fewer than you might normally have to use. There are some times, though, where they might still be useful, and this is one of them. In this case, what I want to do is at the level of county from the table with more counties, all of them in this case, I want a min cases, and if a null comes back, the zero null is going to convert that to a zero. So now cases all counties, notice that it landed in the MN counties level because I referenced that level of detail. So they will land in one of two different places, the table that matches its level of detail, or down here in what we refer to as the neutral zone. So you'll see as I go forward, there will be another one I create that lands down there. And those are essentially calculations at some level of combined table level as opposed to a single table's level of detail. So I bring cases out here. Now we can see that we should have numbers filled in, and we do. I have zeros now for all of the missing counties. So now when I create a map like this, I can then, instead of using that one, I can use this one. Now my counties fill in and I know which ones they are and I see their population. I've got counties or cases across all counties, which I can also bring in, and I'll just put that on the tooltip. And we can see, okay, here are the counties with zero, right? Now that I've got this cases across all counties, then I can do that per capita calculation. So let's do another one. And this one we'll go ahead and call cases per 1,000. And again, this one's just a little bit longer. There's a few more closed parens. And essentially what I'm doing is I'm taking population and dividing it by 1,000 and then dividing that into the case count by state, or excuse me, by county. So cases per 1,000 is one of those calcs that involves information from both tables, and it lands out here in what we kind of refer to as the neutral zone. So I can put that into label, for instance. I may want to use cases to color the map as well. If I were to do that, what my eye should be drawn to are the counties with the highest number of cases. So if we didn't have cases per 1,000 on the label, then you would naturally jump to Hennepin County, which is the most populated county in Minnesota. It's where Minneapolis is, and right next to it is Ramsey, but it's not necessarily even as dark blue or green in this case as Stearns or Noble. And those are counties that I know don't have real high populations, but they have a pretty high count of cases. So let's go ahead and put that back in. And we can begin to see that the counties that are jumping out, if you didn't know the business and where they were or the climate in Minnesota, you wouldn't necessarily know. But if you're like me and you've driven through this part of Minnesota in the summertime, it's usually your nose that lets you know you're closer to the meat packing plant that happens to be in Nobles County before you even see it. That's pork, and there are Hormel is in the southern part of Minnesota, so they're definitely connected, although the county they're in is not as bad. But you can see up here, Stearns is where, if anyone's ever eaten Genio turkey, that is where their headquarters and where they do meat packing up there. So the population of nobles, for instance, is only 21,500, but over 1,100 cases. So it's pretty telling that, you know, they've been hit hardest, obviously, by this, but in that county with only 21,000 people, and it's, you know, there aren't a lot of businesses down there, people who need to work don't really have a lot of choice, and so what was sacrificed in this case was their health. So the highest count, of course, isn't necessarily the biggest problem, so I may want to actually color that differently, or, you know, maybe by the cases per county, same as what I'm using as my label. So let's do that. Cases per 1,000. And now the biggest problem is here, right? A little trick in situations where you have a lot of similarly spaced numbers and then a few that are considerably larger, you get a sort of a washed out looking map. And so one little trick that I like to use that I learned in you know, 50 tips and 50 minutes type of presentation, has nothing to do with relationships, but I'll use it here anyway because it's quick. Is simply set whatever you're using for color to a percentile, and that may or may not look better. It tends to kind of hide the fact that this is our biggest problem. So in this case, it may not be best, but it's a good one to know. Anyway, I'll back that up because I really want Stearns County to jump out. Okay, so taking that one step further and putting it together in a dashboard, we may want to, let's just add that new cases per 1,000 field into here. And in the dashboard now, if we were to sort by that, put them at the top and make it interactive, we can begin to select maybe the counties that are getting hit the hardest for whatever reason. If, for instance, maybe we need to proportionally, you know, appropriate funds to, you know, lend more help to counties that are getting hit harder, and certainly on a cases per 1,000 basis. So what did we just see? Well, of course, the power of relationships. And just to recap, when we first brought out counties, right, with the relationships data source between the two counties, without having to say I didn't want to use a join, I got the correct number of 87 counties in Minnesota. No join was needed for that. And then when I brought the other county field in from the counties with COVID cases in, suddenly I was using an inner join. And then when I brought cases in from the same data set, it went from an inner join to a right join. And that gave me the answer to how many counties plus whatever else do we have cases in. And then to the next question of which counties have no COVID cases, I started over, and in this case, I brought in counties from both sides, and then I brought in the, I just used the number of records for the all counties data set, and that gave me a left join, and then I made sure to reorder my counties on the row shelf just to bring nulls to the top, and that made it very easy to see where the nulls were, which meant those were the counties with no cases. So that was a left join, essentially. All I had to do was rearrange my viz, though. I didn't have to do anything to my data source. And of course, the 88th county, that really came up in the second one. When we actually did the same thing to sort nulls to the top, we saw that the one null in the all counties data set was the unknown missing data that had 20 cases in it from the counties with COVID cases data set. So that showed me that something that I would have missed with an inner join, which was the unclassified counties with 20 cases in them, which is an important number. So no missing data, all with a single data source rather than me having to go change join types or create multiple data sources to answer these different questions. So there are a couple of cases where you may still want to use joins. And remember, joins are still available, and you will still be able to set the join type that you need in situations such as inequality, where, for instance, you might be joining on a date field and you want to do greater than, less than type of thing to limit the range of data that comes back. Or if you're using entitlement tables in your database and you want to capitalize on a user ID and use that as a filter to make sure that they only see the data they're supposed to see, you would need an inner join to make that happen. So you wouldn't want Tableau to decide what join type to use in situations like that. You can specify that we'll always use an inner join. And if you're uncertain about whether or not you need a join, then start with relationships. So knowing that, and probably not being new to Tableau, there are different audiences who may watch this. If you're not new to Tableau, you're used to the old way. You either did what you needed to do in terms of summarizing tables, joining them the way most people would use them, and creating calculations to try to handle other situations. You still want things to work the old way, or you're just used to doing that. But you believe that this can reduce the number of data sources, as you just saw demoed. But it's really not about you, it's about your end users. And you want them to not only continue to trust what they've been using, but for their trust to actually increase. Then before you actually move forward, you might want to see how it works behind the scenes. And so you might start with data that you know real well and that is simple. Try just 2 tables, because that's really all you really need to see everything that these relationships can do. And imagine if it can do everything you just saw it do between 2 tables and use every join type needed. Imagine what it can do when you start to make more complex data sets and involve more and more tables than just the 2 that I showed you. But to see what it does, start with 2, where you understand the data that's on both sides. You can use a single table for validating, and the way you might do that, let's say you're comparing in like versions. You have 2020.1 side by side with 2020.2. If you turn on assume referential integrity, it should use the minimum number of joins, and when you're using data from only a single table, then assume referential integrity, will make sure that that's the case, versus if it's not turned on, then you're going to be using more joins than you probably need. And that might be a good way to validate between old and new. And of course, if you really want to see what's going on behind the scenes, then perform like actions across 2 different versions, same data set, and turn on the performance recorder and compare the differences in SQL. Now, there is more to it, of course, and I pointed out just one snippet from the e-learning. We've certainly updated all of our help as well, as you can see. If you just want a quick intro, then that first link, if you go there, you'll find about 5 different videos. Not a single one of them is even a minute long. So you'll get a great intro there to what they are. It'll help you with some of the terminology, perhaps. And then the help, of course, is linked out to other topics within the same area. So you can get the intro, or you can find your way to the performance options. And also, if you were to dive into performance, you would probably learn very quickly, if you haven't already, that you need to know a little bit more about cardinality and referential integrity, which essentially is the way that you can tune your data sources to become more performant. And so I just put a couple of links. Of course, there are plenty out there in the wild, thanks to Google. I just put links to the same place that I've used in the past that happen to be pretty good for just basic high-level stuff. And as I was learning this before I made ready for you, I noticed a few things myself that I just thought I'd log for just general purpose. For instance, if you just want to see what migrated data looks like when you are bringing data from another older data source, you can simply copy a sheet from an older version of Tableau and paste it into 2020.2, and voila, you get migrated data. So it's because, of course, when you copy a sheet, it has to bring along whatever data source or data sources it is using. So that's one very easy way to see what migrated data is going to look like. When you are using the legacy style, when you actually go into the physical level and you're joining the old way, assuming referential integrity still works the way it would in older versions of Tableau. But of course, for validation, if that's what you're using it for, just remember that you're going to use joins as soon as you start involving more than one table. If you were to export from 2020.2 from a data source that you have used relationships for, then just know what's going to happen. You're going to essentially only get the first logical table and whatever physical tables are in it. So be aware of that. And finally, for those of you who never noticed that export as CSV came into the product, as I did, I think it was one of those unheralded features that just kind of showed up. If you right click on a data source, in the old version, you get essentially that merged result set, that combination of tables that that data source is. But if you do it in 2020.2, because we maintain each table's level of detail and granularity the way it is, you can basically get a CSV from each table if you need it. For whatever reason, if you needed to get a CSV out of that data source, you can do that. So that was a pleasant surprise as well. So with that, I wanted to thank you for listening to this video, and I hope that you will take advantage of the relationships that are built into Tableau.